Hey all, today we're going to talk about exceptions and errors, and I got to be really honest. This is a thing that I'm going to screw up occasionally. I'm occasionally going to call exceptions errors, and that's purely on me. Those are different words with different meanings, and we should try to keep them separate. So I'm going to ask you to do as I say and try to avoid doing what I do, which is a mistake. So the story is exceptions and errors are very related, but slightly different concepts. So, an exception is the computer saying that it can't do what you asked it to do. And an error is the program not working as you intended. Exceptions are often, but not always, the result of an underlying error. What I mean by that is usually if the program's throwing an exception, it's because there's an error in the programming that's causing that exception to occur. That's not always the case. Sometimes you'll get exceptions that can be the result of like a network connection error, um, which isn't really an error, right? It's just the network's down. And so that exception is just telling you, hey, I can't get a hold of the internet broadly. Please deal with that, right? Um, on the other hand, we often have like array index out of bounds exceptions, and those are usually a result of a logic error in the programming. I'm definitely going to screw this up. Please do correct me if you aren't sure or if I misspeak. I'm trying to be better about it, but it's a work in progress. Okay. Java is designed with two kinds of exceptions in mind. There are checked and unchecked exceptions. Unchecked exceptions, which extend what's called the runtime exception, are exceptions that happen as the program runs. Um, these are often the results of programming bugs or user inputs, and these are kind of not required to handle. So things in this vein are null pointer exceptions, array index out of bounds exceptions, arithmetic exceptions, the division by zero exception, that kind of thing. Checked exceptions are things that the compiler is going to check for you. So those are extensions of the exception class, but not the runtime exception class. And those get checked by the IDE. So you're supposed to do some handling with these. Try catch blocks are a thing I'm going to teach you to use later in this video about how to handle those. Sometimes these are called recoverable exceptions. And examples are things like IO exceptions, where it can't get a hold of the keyboard or something, or file not found exceptions, where the file doesn't exist on the user's computer, or it's not in the correct spot, or has the wrong extension, or whatever. Um, and on top of this, just to be extra confusing, Java has a couple of things that it calls errors that are, think to my mind, technically exceptions, but it's going to call them errors. These are usually issues with the Java virtual machine, which is kind of the fake computer that Java actually builds to run in. So those are things like out of memory errors or stack overflow errors. So out of memory errors are actually a pretty common occurrence with Minecraft servers. That's just where you haven't allocated enough memory to load the world. Stack overflow errors happen when you have too many recursions called or something. Okay, the distinction between all of these things is a little bit artificial and doesn't matter really, honestly, as much as you would think it does. The important thing is to try to anticipate what exceptions your program is likely to throw because of network connection possibilities, or file not found possibilities, or user input issues, or if it's reading numbers out of a file, if the data in the file is not as you expect or corrupted or something. That's where you're going to want to try to do some handling. So the tool I'm going to show you to do that is try catch blocks. That's what I want for exceptions. Okay, so errors are a bit more important. So errors are to my mind, come in 3 types. Some people will only distinguish 2 types, but I'm going to go ahead and give you all 3 of what I think are errors, and you can argue with me about whether one of them exists at all. So the 3 types that I identify are syntax errors, which is there has been code that is mistyped that causes things not to compile. So that's you forgot a semicolon at the end of a line, or you typed in the name of a variable that doesn't exist, or you've called in a variable that's outside of the scope or something like that. And then there's semantic errors, which are, to my mind, typing in the wrong variable name. So like say you have say you're moving some object around on the screen and you're using X and Y. If you accidentally reverse the Y and X, that to my mind is not a syntax error because the code is going to compile. It is a semantic error. You have simply mistyped something, and so the code itself is causing this action to be unexpected, and that's due not to failure to compile, but due to some little flipping in there. It's not that you thought it went the other way, it's just that you typed it the wrong way. That brings us to our third kind of error, which is logic errors. So logic errors are issues in the way you designed the code. So if you designed the code a certain way, but it doesn't work the way you thought it should, that's on you. That's in your brain, right? So logic errors are things like, I thought this was going to execute 8 times, and so I put in numbers, and it executes 9 times. The fact that it executes 9 times isn't on the computer. It's not that it's not compiling. It's not that I typed anything wrong. It's that I thought of it wrong, and so I typed it in a way that ended up causing the computer to do something that I didn't expect. A lot of logic errors, by the way, are where you get exploits in video games. Like these kind of, infinite money glitches in games where you can, like, sell an object and then crash out of the menu and then come back in and you have both the gold from the sale and the object still in your inventory. That kind of crap is logic errors. So it's not acting the right way because we designed the program in a way that caused this weirdness. Some people will tell you that semantic errors are logic errors. I tend to disagree because when I'm looking for a logic error, I'm looking at like the structure of the program. I'm not usually looking at the code. I'm doing something like analyzing a flow diagram or looking at a UML diagram and trying to figure out why it's acting strangely. I'm not usually looking through the code. To find a semantic error, I'm literally just going through the code line by line and making sure that each variable is the right name and that it's in the right position. I find semantic errors to be really, really hard to find, personally. Like, my ADHD does not deal well with me trying to type, and I occasionally mistype something, and then it's really quite hard for me to go find those errors because they're often making things act in an unexpected way, but that code's all compiling, so I'm not really sure where to start looking. Logic errors I find a little bit easier to deal with because they're just kind of oftentimes quite a big issue. So let's move over to some code. I wrote all this out. Everything I just said is written out here basically. So you can take a look through that if you missed something I said in there. All right. Let's get a little bit of code written. So first things first, I'm going to go ahead and cause an exception. So the exception that I'm going to aim at is what's called an arithmetic exception. So let's just do, let's do system out println, and we'll just try to divide a number by 0. So we'll do 4 divided by 0. Um, bit of a thing here. Unexpected token. Did I spell println wrong? No. System out println. Oh, okay, great. So we're looking for exceptions, and I just actually caused a logic error. Well, I caused a. I don't know. This one's a little weird. I want to say this is a. I want to say this is a logic error because I just put code in the wrong spot. That would actually also kind of be a semantic error. If I hit run on this though, it fails to compile. So really, honestly, what I have here is a syntax error. So I need to take that thing. I need to put that in here. All right, great. So running this code, I'm going to get an exception. I'm getting an arithmetic exception. It tells me it's divided by 0 at, gives me a location. Great. This red thing is called a stack trace, by the way. That is a very useful thing to have. This here is kind of the content of the error message. So let's go ahead and I'm going to switch this to a number that we can actually divide by. So I'm going to go ahead and get a 2 there. Cool. All right. Let's deal with this. So this is going to be me trying to do what's called handling. So the way I'm going to try to handle my exception is I'm going to use a structure called a try-catch. So a try-catch comes in some blocks. And the blocks are usually a try, a catch with what are we catching, and then lastly a finally. Oops. Okay. In Python, these are try, catch, else, finally. So there's one more piece in the Python version. In the Java version, there's what's the thing I'm trying to do that might cause an error, or an exception rather. Jeez, I am going to say that wrong so many times. So we've got a try. This possibly could throw an exception. That exception is going to be caught by this catch block. Assuming that I've got the right kind of exception in here. So here I know that this could cause an arithmetic exception, and I'm going to call that exception E so I can deal with it. And then we're going to do something like, let's do system.out.println, and we'll do e.toString. So you might notice there's lots of stuff here. These are all the different things that an error has. So the two that you're going to want to use the most are going to be toString, which turns it into a string, and printing the stack trace, which is going to be another kind of common thing that you're probably going to want to do. So I'm just going to do the toString method here. That's just going to go ahead and take my exception, convert it to a string, and dump it into the console for me. And then here in the finally block, I'm just going to do a simple system out.println, and here I'm just going to print the string finally, just so you can see where that's running. So the structure of these is we try a thing. If it causes an error, we'll do this catch stuff. An exception. If it causes an exception, we'll do this catch stuff, assuming that the exception that it's tossing is, in fact, this exception that's the kind that we catch. You can catch a bunch of different kinds of exceptions here. You shouldn't, by the way, just do nothing in those blocks. You should do something, unless there's a really strong reason that you want to just do nothing. This is captured in a thing called the Zen of Python, which is I find to be pretty good computer science habits generally. And the one that's applicable here is errors should not pass silently unless explicitly silenced. So unless you very explicitly wanted that error to do nothing, or that exception to do nothing, you shouldn't just let it happen. Okay, so our try block here, I'm going to go ahead and put in our little print here. And I'm going to switch this back to trying to divide by 0. And we'll see what the distinction is here. So when we run this, with it in our try-catch structure, I got an arithmetic exception. I got its message here, but I didn't get that stack trace, and the rest of the program actually finished executing. So let me put that down at the bottom here. So I'm just going to put this guy, and this is going to be, we're going to go program finished down here at the bottom. Okay, so let me make that distinction real clear. So here's running with the try catches. Here is me taking this guy out and just pasting him there. So in this case, when we hit this exception on line 44, we never even did the rest of this stuff because the program crashed out after hitting that exception. So this is a useful thing to know. If we hit an exception, the program usually stops dead right there, dumps its guts into the console, and says, see you later. If we want the program to continue even after running over a little bit of a speed bump here, we'll use that try-catch structure to go ahead and catch that exception as it happens, and then we'll go ahead and execute. This program finished thing is just me pantomiming. There might be more stuff that happens in the program. The finally block, that always executes regardless of whether the try or catch happens. So let's just try printing out 4 over 2. Should get 2. The finally block just executes anyway because it always executes anyway, and the program finishes. This is essentially how this structure works. So to make a couple comments, here we're trying something that may cause an exception. Here, if the try stuff, so if there was an arithmetic exception in the try block, this will execute. The finally block always executes. So things in the things you might put in a finally block are if you're opening a file and then you're trying to write some stuff to the file, you probably want to make sure the file's closed regardless whether that writing was successful or not. So that's a case of something that I might throw into a finally is like a file close. We might do things in the finally that are just like, you tried, congratulations, right? Stuff like that. And then we might have the rest of our program down here. Okay. Couple of things worth noting. Printing the stack trace might be a good idea. That's a kind of last thought here. We should probably also make a method that throws some errors. So let me go down here a bit, and let's actually define ourselves a method. So I'm going to make a public static void method that's going to do let's do print string multiple times. Okay, and in good coding practice, I'm going to write one of my little Java docs here. Remember, those go up above the method that you're writing. So my little method here is called print strings multiple times. We're going to expect to get a string that's going to be, I'm just going to call this string to print. And then I'm going to get an integer that's going to be a number of times to print. Okay, and in here, what I'm going to do is I'm going to do for an integer I starting at 0, as long as I is less than number of times to print, and increasing by 1, we'll go ahead and do a print line, and the print line we want to do is going to be our string to print. Okay, now let's write our little Java doc here. We've got some parameters. Oops, it gave me an option there. Okay, we've got one parameter, the string to print. This is the string. We'll print multiple times. Let's see, we should also be able to get ourselves an at parameter, the number of times to print. This is the number of times. We'll print the string. And I'm hoping that since we're talking about errors, you're thinking about what kind of errors this thing might throw at us. Sorry, exceptions. Since we're talking about exceptions and errors, I'm hoping you'll think about what kind of exception this is about to throw at us. So there's another thing we can put in here, which is what does it throw? Probably want to throw something like an illegal argument exception. That's going to be because our in the case that our user gives us a number that doesn't make any sense. So let's add that in case of a non-counting number. So let's see here. We're going to need some kind of a statement to check that. So we're going to do something like if the number of times to print is less than or equal to 0, we'll throw a new, and we're going to throw a new illegal argument exception here. And this is where we get to put in what that argument should, what that exception should say on it. So for ours, we can say the number of times to print must be greater than 0. So let's cause that error here, or sorry, let's cause that exception here. So I've got my try block, that's just kind of working. So down here, after my initial try block, let's go ahead and call that method. So we'll call print string multiple times, and we're going to call hello here, and we're going to try to print hello -2 times. So let's hit run on this and see that we actually got our exception tossed. It says what we said it should say. It prints out the stack trace in the same way that a normal exception would print out the stack trace. Then we can go ahead and put this into a try-catch block, right? So we can do something like, actually, I think I've got a perfectly working example for a try-catch block. So we could go ahead and put this into a try-catch block. We would, instead of catching an arithmetic exception, we would go ahead and catch an illegal argument exception in that case. We'd say, oh, sorry, you didn't enter a correct number of times or something. All right. Hope this is helpful for uh, your own process with errors. You can look through. There's a lot of exception types out there. You can look through some Java documentation for exception types. This is actually a really good use of AI to ask which exception type would maybe be the best fit for the scenario I'm in. That's actually a really good use of AI. You might want to check out several different options. So you can ask, like, what would the options be for this kind of thing? Um, there's way too many exceptions for you to probably keep track of them all. The other thing you can do is if one of the exception types that exists doesn't fit what you want it to be, you can actually define your own exception types. I encourage you to maybe wait on that for a bit. So while we're just getting started, let's stick to the exception types that are built into Java. After we've had a while, like as you're getting ready to write your midterm, that might be a place to investigate making your own exception types and then raising those or throwing those. All right. Thanks, guys. I will catch you on the next one.